All right, so we're going to get some practice with our other segment relationships we learned about in the last video. And why don't we do it in a word problem? I mean, why not, right? So part A, archaeologists found part of the circular wall that surrounds an ancient city. They measure the distances shown. The 272 meter segment lies on a line through the center of the circular wall. What was the diameter of the circular wall? So, side note, this reminds me of one of my favorite places I've ever visited, an ancient city called Petra that's in the country Jordan. When we're done with this example, you should Google Petra, look at all the images. I have been there, and to this day, in all my travels, it is one of the coolest places I've ever visited. I highly recommend it if you ever get to the Middle East. Okay, anyway, back to math. Let's redraw this. All right, so we have a circle. This is the circular wall in question. This is surrounding the ancient city. We can see that there is a segment. Let's say we'll put it out here. It's going through to the other side. That is that 805 meters right there. And here is our 310 meters. Now, they said the 272 meter segment is, it lies on a line through the center of the circular wall. So here is the center of our circular wall. So that 272 meters is on a line. I'm going to go ahead and draw through the center to the other end, and we know that this is 272. And the question is, what was the diameter of the circular wall? So the diameter, I'm just going to go ahead and label with an X. This is the diameter right here. That's what they're asking for. All right, so this is a secant. So we have secant segments. All right, so what we saw in our last video with the theorems, the product of, so here's the point where they meet out here. The product of, from this point to the circle, 310, times from this point to the other edge of the circle, times that whole segment, is equal to the other secant from here to the circle, 272, times the whole segment, 272 plus x. So that's how we're going to get an equation to solve for x, which is the diameter. So the theorem says 310. So from our point to the circle, that segment times the full segment, 310 plus 805. We'll do that math in a second. That will be equal to, with the other secant, because these two secants share an endpoint, that's why we get to have this relationship. From the endpoint to the circle, 272 times the full secant, so 272 plus x. And I like to put x first, so maybe I'll say x plus 272. All right, so first things first, why don't we go ahead and add those together? That's 310 times 1,115. That's equal to 272 times x plus 272. All right, so now let's go ahead and we can multiply 1,115 times 310. We're going to get into some big numbers, so just a heads up there. That is 345,650 equals, now let's go ahead and distribute over here, 272 times x And then 272 times another 272 is going to be 73,000. So positive 73,984. Why are we working with such big numbers? Well, this is a real life example, and this is just how big things are. All right, so solving for x, we're going to subtract 73,984 from both sides. Let's see, that's going to give us 271,666 equals 272x. And then our last step is just to divide both sides by 272. And x equals 998.8, so we'll round to the nearest tenth, meters. And then remember, x represented our diameter, and that's what they were asking us to find. So the diameter is 998.8 meters. And we were using the secant segments theorem. All right, part B. What is the value of A? So we have to just decide what kind of segments we have. Do we have chord, secant, or do we have secant tangent? So these are secant tangent segments. So the theorem for your secant tangent segments is, it's similar to what we did above. Here's the secant and the tangent meet at point P. So we're going to take the product of P to the circle A times the whole secant, A plus 9, is equal to Q to the, P to the circle 6 times P to the circle again. So A times A plus 9, again, that was P to the circle is A times the whole segment is A plus 9, equals P to the circle and the P to the circle again. So 6 times 6, or 6 squared. All right, let's go ahead and do some solving. We'll distribute our A. A times A is A squared. A times 9 is 9A, equals 6 squared is 36. We can see that we're going to solve an equation that has a squared with another term. So let's try to factor this. We'll get everything to one side, 0 to the other side. I'm going to subtract 36 from both sides. So A squared plus 9A minus 36 equals 0. And now we're looking for, do we have factors of negative 36 that add up to a positive 9? And we do. That's going to be a 3 and a 12. And if we have a negative 3 times positive 12, we get negative 36, and negative 3 plus 12, we get positive 9. So this is going to factor into A minus 3 times A plus 12 equals 0. Once it's factored, you set each factor equal to 0 to get our solutions. This first equation, we're going to solve for A by adding 3 to both sides, and we get a positive 3. Second equation, when we solve for A, we subtract 12 from both sides, and we get a negative 12. So we did get two answers mathematically. When we look back at our picture, we can see that A is representing segment PR. This one's not going to make sense. PR can't be negative 12 units. So in the end, we're only going to have one solution that works in the context of this problem.